Brilliant. Thank you very much for having us. It's really nice to meet you all and to be talking to people in quite a long way away from us. So we all belong to a project called Young Minds Big Maths, um, which, as it kind of sounds like, is all about kind of trying to just do really interesting, exciting maths with young children. And Claire's already shown you the booklet, which is great. So hopefully some of you might have already got that. If not, we've got a QR code to download it digitally if you want it, really, really soon. But also there are lots of copies with Claire and Sue. So do try and get your hands on one of those. So I think she'll introduce ourselves just quickly. So my name's Rachel and I'm an associate professor of maths at Durham. Sarah, do you want to go next?
Hi everybody, my name's Sarah Dixon-Jones. I'm head teacher of 2 nursery schools in Sunderland. Catherine?
Hi, hello, I'm Catherine. I'm one of the teachers working under Sarah in one of the nursery schools, Horton.
Hi, and I'm Sophie. I'm also in the maths department at Durham University. Yeah, I think that's all I need to say.
Great. So this webinar, a lot of the webinar is specifically about kind of ramp play. Well, not so much about the booklet actually, but about just ramp play itself, and engaging children in thinking about maths around that. But we're going to tell you a little bit about the background of our project, and we'll also give some practical suggestions. So there's a QR code. When I've stopped talking, I'll put the link in the chat as well. I think I'm now going to pass over to Sarah, who's going to tell us about the background of Young Minds Big Maths.
Thanks, Rachel. Yes, you'll just have to kind of keep all of your ramp thoughts to one side, just because we couldn't talk about the ramp booklet without kind of explaining the start and where it came from. So what we've just got on the slide in front of you that you can see it is, I suppose, how it was born and how the project came about. And I think I can speak for all 4 of us today. When we initially started meeting, we had absolutely no idea that 5 years later we would still be having groups and the impact would be as great as what it has been. So it has been a really, really special journey. Ultimately, like that slide shows there, it's a collaboration between early years educators and the university mathematicians. It was initiated by Catherine and myself, and conversations that we were having in nursery regarding the changes to the EYFS back in 2020 and that maths curriculum, and removing that early learning goal that was all around that shared space and measure. It very much has grown to include more early years settings across the north and northeast. And again, ultimately, that aim is to equip early years educators for child-led, playful, purposeful maths. I think, that, sorry, I'll go back. I think what it showed is kind of how policy and guidance can really inspire creative research, informed practice. And again, I think it's that part that we're really passionate about, and we're excited that it's had such a big impact. The collaboration and the fact that it explored initially, yes, it was very much just something that was happening within our nursery school and the university mathematicians. I think the fact that it grew and developed has shown that that impact can be seen in various different settings. It wasn't around something special that we were doing in our nursery. There was something really special that we wanted to try and capture. And it equips ultimately educators, enabling them, giving them that confidence, the knowledge and the tools. And I think just when that practitioner was talking about ramp, then I think sometimes what we found is that, yes, you would see things happening regularly, but staff didn't always have the skills and the knowledge to know how to extend it. Right, sorry, Rachel.
No, it's fine, sorry. It's hard to know when to do it. Yeah, tell me if I need to go back or forward.
It's fine. Ultimately, in a nutshell, it is a very unique and different CPD model, which the special part, particularly for me as a head, has had an impact on staff and an impact on children. That kind of slide there, I suppose, highlights how that high quality early years maths learning is supported by that professional dialogue. So we had meetings, the team of staff from Horton Nursery and the team of mathematicians. We met every half term. And it was really very organic. And I think that's the bit, that's why I can sit and talk about it. I'm really precious about early years, and about, really high quality interactions with children and keeping the child at the heart of everything that we do. And that's something we're really passionate about. And I think what was really special is that it wasn't a project, it wasn't a scheme of work that we pulled off the shelf. It was about the children's interests. It was about things that they were doing, and staff were just carrying out their general normal observations of children and taking those observations to the mathematicians and saying, this is what the children are doing, this is what we're seeing, kind of what is the maths? What does that mean to you? So that focus was always on children's thinking and children's play. The mathematicians never ever said, you must go and do. They didn't particularly have ideas of next steps, really, Rachel, did you? It was literally, this is the maths that we can see. And when I say we talked about really high level maths, I mean, me and Catherine used to come up, because it all happened, it started in COVID. So all of the meetings were on Zoom. And we would sit independently in the nursery, and the meeting would be over, and we'd script it, take notes. And we'd kind of come out and meet in the cloakroom or in the staff room and just go, wow, like that was a lot. So the mathematicians really challenged us and gave, the staff really big concepts, things that we would have never talked to the children about. But that, they never again said, you must go and do this. It was then the staff's time to really unpick what they'd said and think, right, how can we feed that back? So the staff took their knowledge of the children, and were able to pick the highlights and know what would work for the group of children. So that learning became embedded over time. And I think for me, this drip effect was what was so powerful. It wasn't a one-off maths event. It wasn't a conference. Every 6 weeks, the staff were meeting with Rachel and her team and hearing about maths. And when I tell you, I mean, we're very passionate and we get very excited about anything early years, as I'm sure everybody on this call does. But Rachel and Sophie and the rest of the maths team had that level of excitement and enthusiasm about maths. And I think at first we were just like, wow. But what happened over time is that love and excitement dripped into staff that were then able to translate that back into the children. So sorry, I do like to talk, but I think we've got time today. So that was kind of how the project worked across the year, I suppose. Then, so that's all well and good, and you'll be sitting thinking that's lovely, but yes, what was the impact? And I think that quote there just really, really sums it up so nicely. The staff suddenly had that buzz about maths. And staff knew that wasn't there before. And like I said, ultimately the project came about because of that change, and it led us to talk within our team about how confident staff felt around maths. And it became apparent back in 2020 that a lot of the staff were quite nervous, quite anxious. If, Ofsted was going to come in and do an observation, the last thing they would have wanted it to have been around was maths. And we said that as early years practitioners, you are looking at children through almost 7 lenses. You've got PSED, communication language, maths is one of those lenses. And for us, it was our dirtiest, I think is the best way to describe it. And part of this programme it became clearer, and it just, for staff to have more confidence to talk about maths, they definitely had a much more positive view of maths. Their knowledge developed, their understanding to be able to support children really grew. They were just ultimately tuned in. And I think it became successful because everybody played to their own strengths. Rachel and her team know maths really, really well, and our team really knew children. And there was never a power conflict. Nobody felt that they were more important than the other. It was just a really, really natural lovely thing to be part of. Like I said, it built staff's mathematical vocabulary, and it created a really playful environment, you know, where children were curious, staff were curious, they wanted to unpick things together. And again, ultimately, we've got a really ambitious and creative mathematical curriculum now. And both of my nursery schools, we take children from birth. We've got our baby room, our 2s and 3s, and then main nursery. And they're quite, you know, they're a big nursery. We've got at the moment about 170 children on roll at both schools. And this, yes, started very much in our 3 and 4-year-old room, but now everybody is involved, and you're seeing that impact across the whole school. So it was a big deal. It was a big deal. And like I say, to see that impact for staff was amazing. But then I think the next slide is that impact on children. And again, you know, as a head, that is what you want to be able to see. We've again just tried to pull some of the highlights there, but I think for us, what we realised is that children do maths things very naturally, and I think sometimes we were missing some of that. Again, young children have surprised us, and I know Catherine has got some lovely examples. They really can do some high-level mathematical thinking, and I think we were all quite surprised. And I think Rachel and the team were at just what the children were able to do and the conversations that they were having as a result of what Rachel and the team were feeding back to the staff that then fed that to the children. So, you know, there was a lot of interest and fascinations that came from the children. And again, I think it developed over many months. I wouldn't want anyone listening to the, you know, any of the slides today and thinking, oh, wow, you know, it took time. It was built upon, you know, children aren't rushed to move on to something else. But there was really deep level learning, and I think that was important. It wasn't about trying to get, like I say, it wasn't a scheme of work where we had to get through quickly. It was really about meeting the children where they were, embracing mathematical words and concepts and allowing them time to explore across all areas of nursery. They discovered that they could make mistakes and that was okay. And I think as well for the children, they were able to see that their ideas, their mathematical questions mattered, that we were listening to them and supporting them to explore things. So it was hugely impactful. And I think I'll stop talking because I've talked lots. Anything else? No, I think that's me done.
Sorry. I think it's over to Sophie now. But
right,
I know.
but now at least my microphone should be on.
Yeah,
yes?
sorry, I had a panic there that I meant to say.
And is my camera on or not?
It doesn't look like it, but don't worry.
Yeah, some people can see me. Ha! Sue is
okay,
nodding at me.
sorry.
That's great. Okay. So fine. So Sarah's talked about roughly speaking, the impact on the early years practitioners and then the impact on the children. I'm going to talk a little bit about what it looked like from the mathematician's point of view. Obviously, it's not about us. The benefit is ultimately for the children, but we really enjoyed the sessions. One of the things we found very exciting is how many very mathematical things the children were doing already. They were constructing things, they were making experiments, they were arranging patterns, talking about shapes, they were measuring stuff. All of this is maths, and we didn't make a very tight boundary on maths. Some of it, maybe it's a bit more like physics or science or engineering or so on, but we reckon maths underlies all of that, so it still counts as maths. And then it's not just what they were doing, it's how they were doing it. So the children themselves, without any prompting, were really aiming for the things that we would also aim for, like precision. You know, can they measure things exactly? Can they fit them exactly? If you're comparing things like, for example, which ramp makes the ball roll faster or something, how do you make the comparison fair by not having other factors that might deceive you into thinking one ramp is faster when actually the other one is? Definitions of things. You know, what actually counts as a square, or what actually, yeah, there are examples later, so I won't go inventing them. It was also terrific seeing how the children sort of took the maths to be their own. They weren't being told what to do. They took the things they found interesting and useful and ran with them. Like, here's this little boy drawing. He has been talked to about right angles. He's got the idea, and now he's got his own question about it. He likes heart shapes. Is there a right angle in a heart shape? Can you find one? What he's drawing on the board doesn't look like a heart to me. It does look as if he might have made one right angle and he's going to make another. But this is his project, asking their own questions and even getting debate going between several children about, is this a heart shape? Is this a right angle? What do you think? Can I draw another one which is different? And it is very much how my colleagues in the maths department behave. What they're talking about might be obscure to me as well as to you, but there they are discussing things, deciding if this is an example of that, deciding if we can do it differently. All this stuff. It feels like really doing maths. And I think one of the things we want to get across to people who maybe maths doesn't play a big part in their life is that maths is open like this and various, and you can explore in a lot of different directions, and it's not just a bunch of little questions that you get asked and the main thing to do is avoid being wrong. That's the sad view of maths that we really want to try and help people not be stuck in, for the children and for adults. Okay. I think we need the next slide. Yeah, so why did we start with our booklet on ramps? Rachel and I are actually really looking forward to trying to write another booklet this summer. It's going to be fun. But first of all, ramps kept coming up in the meetings which we were doing with all the different nursery settings. There's huge potential for maths exploration. There's so many different aspects of maths that you can think about. Rachel and I know about rather different kinds of maths. Rachel's a statistician and I'm a pure mathematician, if anything. So we had different enthusiasms, and we started with a booklet that we thought might be 12 pages long, and it ended up 36 pages long because we kept thinking, oh, they're also doing that. That's really interesting. So the children find it fascinating, and we found what they were doing fascinating. So it just seemed like a natural thing to write about. Okay, I think, yes, I have one more. So what the nursery people at Houghton got really good at was spotting the maths that was happening. And one of the main things at the bottom, to jump to the bottom of the page, is that you don't have to have numbers involved. There are a lot of things you can talk about which you could put numbers to, maybe later in maths at school or at university you might, but they're still mathematical ideas even before you put numbers to them. So spatial language, talking about the ramp is on top of the crate and it goes under the bridge. Those are maths concepts. All the properties like size and length and weight and angle and slope and speed and so on, again, those are completely mathematical things. They're things you could put numbers to. You could measure the length in centimeters or the speed in miles per hour or whatever it might be. But you have to have ideas about these things before you start putting numbers to them. That's the second stage. Connections, trying to make relations to see how these things are connected together. The big ball went faster than the small one. I don't know if it always would, but even just to spot that it did in this case is a mathematical thing to notice. And then once you've done enough experimenting, you might start kind of bravely making predictions before you do something. And there was lots of that happening. The children would say, I know this one will go fast, because they've done lots of experiments before and they know that the setup they've got is the kind where things go fast. related to that is having an idea of what causes what. Why did it stop? It stopped because the ramp was too flat. All of those are very mathematical comments, and we should notice them, we should appreciate them, we should kind of invite them, value them. Okay, yeah, next one. So that was sort of if the children are talking about it. Some children will be less keen to talk about what they're doing, they'll just be doing it, and that's fine too, but you might have to look a little bit harder to work out how they're thinking. If a child does the same experiment a lot of times, then they're really interested in it, and they might be trying to work out some rules, get some general ideas, some predictions, some connections, like on the last page. Or perhaps they're trying something, but they keep changing it a little bit. Maybe it's not doing quite what they want to do. We've got an example of that later on, which I think Catherine will talk about. Or it's particularly clear if you've got two setups, and one has a bigger ball than the other, one has a steeper ramp than the other, whatever it is. There's clearly some thinking going on. And as early years educators, you know very well how to sometimes let the children just get on with it, and sometimes put into words what you think they're thinking about, so as to give them practice with words. Okay, I think that's me, and it's Catherine's turn.
Hello, can everyone hear me before I delve deeply into the world of ramp play? Yeah, good. Everything that you've heard in the background kind of telling you how Young Minds Big Maths was born, the theory behind it, I'm going to try now and put it into practice. So what I'm going to show you is some little snippets, but again, kind of elaborating on what Sarah said. These are things that happen over time. So I don't want anybody sitting there thinking, oh, that's all well and good. It happens day after day after day. Like, it doesn't. It's a build up and it's a relaunch of new ideas that we would take back to children. Unfortunately, we're trying to share as much of those as we can in a short period of time. So it is just little snippets of things that we've pulled together. The booklet does show some of these snippets, and hopefully you can get your hands on it and you can see a bit more around the bigger scale of what it was like. But just for a little bit of an idea, we've picked different slides for different reasons to talk to you about. But this one particularly was thinking about that mathematical reasoning, which we know is really important for our young children in early years. And it's about them being able to reason and understand things fully without rushing them onto that next kind of concept or word or skill that we want to introduce them to. But if I can draw your attention here, firstly, just into the kind of language that you could see on the screen, there are children's words that they will be using. Yes, they've already been exposed to these concepts earlier, and this is them now in independent play where they are consolidating these ideas for themselves, and us as adults are hanging back that little bit, which I appreciate can be hard, but again, we know that we have to a little bit. Our observations really influence our own thinking as practitioners and understanding what children understand. So it is important to step back at times and give them a chance to make meaning of things. And this is that chance. This is them doing that. So you can see that you know, it is complex thinking and it's definitely mathematical reasoning. So in that first statement, I've made this ramp a flat one. When I put my car on it, I have to push it to make it go. So he already knows that actually he's made a ramp, but he's got no movement. So he's questioning why have I got no movement, and he knows that he needs to give that force to make that move. Then you've got, I was right, look, it's going down, it's going to go down back the hill by itself now. So he realizes that by can't even speak now, by changing that ramp positioning, it will then start to move because it's not that flat one anymore. But I think, again, this language will be language that you are hearing probably yesterday in your nursery, perhaps in your setting. Our children, I will stress, I always say to people, we are no show home. We live and breathe children, and then we have the same children that you have in your school and setting. We are no different, but children are so capable if practitioners can just step back a little bit and listen and observe. But when I say listen, I mean really listen wholeheartedly to what children are saying and doing, and then using those observations to inform your next steps. And thankfully, through the collaboration of Young Minds Big Maths, we had that team there. So how could you take an observation like this, take it back to the team and say, but where do I go with this next? And like everybody, I don't have the answers to everything, but I have a team. And I think we all need to as well kind of find those people that can support you in that area that it might be. And for us, it was maths, and it's ever grown and it's blossomed to the mammoth degree and that it is, and it's huge for us. And I would say maths is probably one of our strongest elements of our curriculum now because of a result of that collaboration. But it might be something else in a few years' time that we need support on again. And I think there's no right and wrong in admitting that. It's just about sourcing the people that can inspire you. And for us, these mathematicians give us that inspiration that fuels us, that enlightens us, that takes that kind of love of that subject to children, which sadly you might agree or disagree with. But a lot of people in society hear the word maths and almost like shrivel up, back away, and just think it's not for me. I'm not mathsy. I'm not that person. 10 years ago, I probably was that person, but they've inspired me. They've totally changed my view of maths from a professional point of view and a personal point of view. And I do view it in a very different way. And I just think it's something that all of us should not be afraid of. But that's me rant over about it. I'll get back to what I'm actually supposed to be talking about.
Catherine, can I just stop, because there's a couple of, oh no, there was a hand up for quite a while. I think it was in Yezi. Sorry, but I don't know if that's still. I don't know, but also, well, Sophie's got her hand up, but I feel like I know what Sophie wants to say, and I wanted to say it as well.
Can I say it?
Well, go on then.
Yeah. Okay, so it's just that this first picture we love, because you could say that's not a ramp.
I think some of us did say that, didn't we? I think we had a bit of a debate about whether it is a ramp.
You might well say that's not a ramp, because it has no steepness and the thing won't go down it by itself. But you also could say, yeah, it's a ramp. It's just one that went flat. And I think one of the things we naturally found in the meetings was that we actually sometimes disagreed. You know, some of us would say, no, it has to have some steepness to be a ramp. And somebody else said, I don't know, I think I'd like to call that a flat ramp. And it also is an example of how mathematicians love to kind of push things to what we literally call the limit, which is saying, you know, well, we get our ramp flatter and flatter and flatter and flatter and flatter and flatter, and in the end, it would actually be flat. But I think we still want to call it a ramp. Just like you could say numbers can get bigger and bigger and bigger and bigger and bigger. And well, if there's an end, we'd call it infinity. And is that a number or is that not a number? Depends who you're talking to and what you're doing with it. And, you know, there isn't a wrong. If your children said, I want to call this a ramp, I would say, okay, let's say we call it a flat ramp. Great. It doesn't, you know, mathematicians mess around with definitions all the time. We make our own. And when we write something, we start by saying, in this paper, I'm going to use this word to mean this. So your children have the same right. So, Rachel, did I do it right, or do you want to add something?
Oh, yeah, no, that's fine. Sorry, but I wholeheartedly agree. I actually thought of something else to say though, which is so in the when people were sharing in the chat, and the lady who spoke, quite a lot of people mentioned wanting to be able to introduce sort of new words and ideas, and I think that's something we don't talk about that much in this webinar, but we do talk about it a lot in the booklet. But actually, in the third, I'm using my mouse, but you can't see it. In the third picture in the quote, you can see actually, so he does start to use words like angle, and he even talks about the acute angle when he moves the ramp up really steep. And so, I mean, that's not like he's just kind of plucked that very suddenly. I think that there's an awful lot of exploring the word angle that went on that year. But I think that is an example in this webinar of a time when a child does kind of use a really mathematical word really appropriately. And I think that you can see examples in the booklet actually of times when children sort of almost like wanted the word angle but didn't have it yet. You know, they would say, oh, it's gone little up the top. I know he says that, doesn't he? But there's others who say, talk about it being really kind of small at the top or whatever. And you kind of think, oh, they really want to have a word for that kind of, you know, the pointiness. And then Catherine and others were able to introduce the word angle, which is exciting. But yeah, so that doesn't come up so much in the webinar, but it does. We do kind of talk about mathematical vocabulary in the book. Sorry, Catherine, we're hijacking your slides.
No, that's fine. Shall we go to the next one?
Yes, let's.
This one is another example again. And I think as well, which I'll point out, you'll see in the photographs that we don't have any special resources. They're very much your everyday resource that people can access. So there'll be familiar things in there in your picture that you think, oh, we've got that in our school, and we see our children doing exactly that. You can probably picture that quite clearly. But I think this slide shows you how children are beginning to take mathematical ideas that they've been exploring over time alongside their real life experiences, and they are combining them together. And this sequence of language that we can hear in the on the screen there is children refining and deepening their understanding. Ultimately, they're taking really close observation alongside repeated experimentation. And I would say again, that's key. Children need to go back to things, and they need to revisit things, and they need to have that time to be able to do that before something is kind of relaunched and a new word is introduced or a new concept is moving them forward. Yes, they need that progression, but they need opportunities to go back and do things time and time again. This is just a little one. The car hasn't gone really fast. This is just a little bit fast. So rather than noticing simply that the car moves, he starts to talk about that speed. So speed comes into play. He's developing that understanding of relative measures, really, between fast and faster, or a little bit fast, and all those words that children use to try and describe what it is that they're saying. He's using no formal units, but he's using that kind of non-standard word, if you like. But then again, you could argue that actually a word is a word, and how is one word more powerful than another word? But that's for a different debate. But I think at the roots of it, there's no right and wrong. These are children's experiences. These are children just trying to share what they are understanding and learning. And again, as a practitioner working with children, we sometimes just have to learn from their words. They actually have better ways to describe things. It might not be that mathematical term that you might use, but again, and throughout this project, we've had lots of debate. Is there a right and a wrong if a child doesn't call a cylinder, but calls it something else? Is it right or wrong? They need to know those words. They need to know those words and understand them throughout that kind of through the schooling and education. And if you think about those tests and exams that they have to sit at points, they do need to know that language and terminology. But I think it's being respectful of the words that they do use and not always correcting them instantly, and kind of allowing them time to refine that language a bit more. He talks about this, the black one is long, I can stand it up while I put more blocks on, or bricks if you build a tower here. So you can see that he is really going from that flat ramp that Sophie explained to really that kind of almost drop. You could argue, is that a ramp because it's an instant drop? But to him, he wants that to go down, so he's finding a way for it to travel. Does it need to be on an angle, or does it just drop? Like, it's still movement. So there's lots and lots of opportunities ultimately for discussion, for mathematical discussion with children throughout their rooted experiences, and the things that they do day in, day out, time after time and time after time. And I hope that makes sense. I feel like Sophie was about to speak there and jump on something.
No, I was just absolutely agreeing that the vertical ramp is also kind of a limit case. You know, it's going as far as you can in steepness, and yeah, you might want to call it a ramp. Yeah.
Mm-hmm. And then on the next side, we've got another kind of example of how children have clearly been playing around with those same gutterings at different positions, but we started to add different things to ramps. Just thinking about earlier when Sophie mentioned mathematicians spend a lot of time thinking about variables and tests, and this is ultimately what they're doing. They're comparing those conditions. Will something affect the way that something will move? But to make it a fair test, it's kind of remembering that. And again, we had lots and lots of opportunities with chats with children around what makes a test fair. How can it be fair? Do we need our results to be fair at the end of it? And ultimately, if you're a mathematician, you need a fair test. But how do we make something fair? So it needs that same starting point. We need the ramps to be mirroring each other in some way. So we did. The children worked on a long time in placing and arranging and getting those blocks to be just right, getting the position of ramps to be just right before we would then embark upon some tests. And our test was, what will affect the conditions of a ramp? What will affect something that's moving? It wasn't necessarily the objects that were moving. It was this point, it was literally the kind of the flow of something. So we had sandpaper on things. We had, as you can see, strips of hessian running down, bubble wrap, anything and everything. Again, those everyday recyclable objects that you can get your hands on pretty easily is what we were using. Because like I say, we're no fancy nursery. We use what we can where we can. So it's an example of children doing a fair test there. I think you can see one child there says it feels funny, it hurts my hand. So it wasn't just necessarily about the conditions of the movement of the object, it was how it was feeling, and that texture all played a part. So there was lots and lots of descriptive language. And I think you'll know that curriculum in early years is very interconnected. You can't singularly pull out one subject. That is very, very hard to do. Everything connects really well. And again, it's appreciating that things do merge together. And I know, like myself, when we have teaching students coming in, they find that that's a learning curve for themselves to understand, isn't it? Because they come in and they're wanting to teach maths, they're wanting to teach history, but everything interconnects and it blends together. And like Sophie said, a lot of science and maths naturally blends together anyhow, but it's understanding that that's all right. That's how early years operates. It's okay, but it's appreciating everything and all language. It's not just kind of looking for the language that you want them to hear or that you want them to use, because language builds together, words build together to get that message across. And for children, they're sharing what they know, and that's our point of kind of making that analysis and understanding, are they understanding this? Do they need repeated exposure of this? How can we then move that forward? But moving it forward within that timely manner is really important. So we've compared conditions, unless Sophie's going to add that mathematical.
Well, I was going to add, am I allowed to talk?
Rachel is. Go, Rachel.
No, I was just going to say, sometimes it's kind of surprising how much math the kids know without even knowing that they know it, if that makes sense. So like when this second quote where they say, if it has no wheels, I'll have to push it down the sandpaper, they kind of know that like the circular wheels will allow it to roll. But, you know, this I think it's a big shell, isn't it, that, you know, it doesn't have a kind of, it's very angular, wouldn't roll. And maybe they wouldn't necessarily put it in those terms. And we've got other examples where it's more explicit that they kind of understand what shapes will roll and what shapes won't roll.
Yeah, I think there's two ways something can go down a ramp. If it does, it can slide or it can roll. And a car is a very clever thing, because the car as a whole looks like it's sliding, but it only slides because the wheels are rolling, right? And that's actually a sneaky thing. That's why wheeled objects are special.
We should have put that in the book. That's not in the book.
Yeah, next time.
That's very deep. Time. Yeah.
Yeah. But so I mean, and the child has absolutely got that sorted, right? The wheels will make the car go down. You know, we didn't think to say it, but they said it on the nose. Good for them.
Yeah, so we've seen quite a lot of examples, some examples of just sort of noticing children's maths, and now we're going to think about joining in. But actually, the first slide here is still about noticing, really, and just how important it is to sort of before joining in to understand what it is that the children are actually thinking about and experimenting with. What do they have a question of their own that they're trying to answer? So sort of going back a little bit to what Sophie was talking about and what Catherine's been talking about, kind of, are they repeating a process? You know, can you sort of see what it is they're trying to keep doing and what they might be trying to learn from that? If they're getting kind of very curious or very frustrated, maybe because something's happening that's unexpected or something's happening that's not quite going how they want it to go. Yeah, can you tell if they're trying to solve a particular problem or achieve something particularly? And yeah, that all really, the kind of point of that is what is their chosen question or exploration. Because one thing that we've seen quite a lot through this project, and I'm sure it's not news to you at all, is that children, whenever we've been talking about them in the meetings, if they've got their own question that they want to answer, they're so invested and so engaged, and they're so keen to kind of, you know, learn how to use a ruler or learn how to I can't think of any more examples now. You know, use something really specific. They're really
one thing is, if they've got one thing that sometimes happens is if they've got a question they're really interested in, they'll start by just saying which goes faster or something, and then or which is bigger, and then they'll think, wait a minute, that's what numbers are good for. And they'll go and find a tape measure or various other very clever, ingenious methods of putting numbers to things, which we have in our book. But nobody said, okay, now you have to go and do some number work. They've actually thought, oh, I think we need numbers for this. And that's lovely to see, because actually numbers are brilliant, but we don't want to be force feeding them to children before they see the point, you know.
And they're so accurate with the numbers, aren't they? When they have got a question that they want to answer, they're so like bothered about getting it right. Because I remember when my kids were that sort of age, if they were doing something where they needed a number, if they were pretending to be a shopkeeper, they would just pluck numbers from anywhere, and it would make, I mean, not that that's wrong, but the numbers wouldn't really mean anything. They would just be like, oh, I need a number. But when they're bothered about, which car's gone the furthest, or which circle is the biggest, or whatever it is, or how many of this are there, they really want to get it spot on, which is really exciting to see. Okay. So yeah, so in joining in, the natural thing, I guess, is to follow what their interest is, so to build questions around what it is they're doing. I think Catherine's spoken a lot about kind of just trying really hard. It must be really hard, but to sort of avoid asking too many questions. Let them kind of, if they're flowing in their play. Is that the right way to put it? That doesn't sound right, but anyway, if they're engrossed, then maybe they don't need any questions at the moment. And give them time to think, because it might be a new thought for them, or it might be that they need a bit of time to put the ideas together. And yeah, so I mean, Sarah and Catherine have both mentioned the importance of time and how all these examples have happened over. I think there was a whole year where there was lots of ramps, where ramps was one of the big things happening. But even aside from that, there's been ramps every year, I think. But it's not kind of 1 hour they talked about this and then the next hour they did this. And just the big thing really is to help them in their mathematical exploration. So we want them to feel like they are mathematicians, that they're the ones who get to ask the questions, and they're bothered about what they're learning. So some examples of the sorts of things that you might kind of do or say. Maybe just join in their wonder and curiosity. So kind of join them in wondering why something happened. Or maybe if they are getting kind of frustrated with what's going on, maybe you could try to sort of support them to identify exactly what the problem is, or to find a solution. So maybe some cardboard is buckling and they'd be better off with a plank of wood. So supporting them to find a solution to the thing that's going wrong. It can be, so we've seen lots of examples where children are thinking really mathematically, but maybe don't put it in very kind of precise mathematical language, which is also fine completely. But sometimes it can be kind of helpful to phrase things in a sort of quite precise way to help them sort of clarify, I guess, to clarify what it is that's going on. So thinking about the height of the ramp, or what would happen if we made this higher or lower, to sort of I guess identify a sort of mathematical aspect of the thing they're thinking about. It can also be really helpful to encourage them to collaborate with each other. So maybe their friend has got a ramp that's doing what they want their ramp to do, and they could work together. Or maybe they are the friend who's got their ramp to work, and they could explain it to their friend. And introducing maths words. So I think Catherine has more to say about this probably, but sometimes it's just there's a really appropriate word to give to them that explains what it is they already wanted to say. And I think that's when it's really good to introduce it. So I really hope that the booklet helps with that, because it has lots of examples of words. But it can take a while and lots of examples to get the word sort of to get them comfortable, for them to be comfortable with the word. So I know certainly with angle as a word, it's sort of quite a hard concept to explain in a way, isn't it? Because it's the kind of pointy bit. It's the pointy bit of a shape, but it doesn't have to be that pointy. This is an angle, and it doesn't matter how long the sort of legs of the angle are. I think that was something that a lot of children thought at first, was that an angle with really long lines either side of it is bigger than an angle with short lines. And then there was lots of examples of ways in which Catherine and the others were able to sort of show them what an angle is and sort of dispel that. But yeah, so giving children time to sort of learn about these new words is really important. So I think Catherine now has some more. Oh, sorry. Yes.
Can I just jump in very quickly, informally, and say, when we say introduce math words in our booklet, a few of them are technical maths words which you might not have expected children this young to use, and we are very surprised that we found that they absolutely could use them and understand them, like angle, and in some other work we taught them concentric circles and spiral, and they absolutely got it and found it fascinating. However, when we say introduce maths words, we're also meaning introduce all the everyday words for mathematical ideas. So for some of these children, particularly somebody in the chat was talking about supporting someone who didn't have a child who didn't have much English but was brilliant at building stuff. You know, for him, maybe to talk just in terms of long and short and, you know, tall and wide, I don't know, and maybe go as far as steep. So, you know, those are maths words. The fact that, you know, all of us adults are in our own language are familiar with them doesn't mean they're not maths words. They're still worth using and getting the children whose understanding is really good, but they're not so quick to put it into words. You can help with that, even with the familiar words.
Yeah, definitely. Thank you.
Yeah.
Okay. Oh, Catherine, I think you're muted.
Yeah.
I clicked the button as well, but obviously not hard enough. Sorry, I'm back.
Yeah.
I think taking on board everything that we've said, I think we know as early as practitioners that we want children to be problem solvers. We want them to solve problems because it's a life skill that they can use throughout in lots of different concepts. But I think for us, alongside that, if we go back to that view of kind of putting it into a maths lens, support and maths in provision is so important. Yes, we'll do group work with children and, you know, we'll introduce things to them. Of course we will. That's how we work. But I think that exposure to your provision is crucial. And with that in mind, if I could say anything to you, I think you need to kind of look at your provision through that maths lens. And if you've introduced something to children, does your provision support the children to allow them time to kind of embed those theories, to take and make meaning of it? So for us, that is something that we do all of the time. It's no good just having something in a bag that we expose children to and that we give them that new word and we let them play around with that idea in that time that we're sitting with them in that group time. It's about, what does our provision then look like? Has it got the things that's going to allow them to take that and make meaning of that? And this is an example of a girl doing exactly that. So yes, she'd had prior experience to ramp play, but she's talking here about, you know, she was watching, I'll be honest with you, she was watching some children. She's been exposed to the language and the way that we work. She hears what's been going on, but she was watching a different group of children building ramps, and I could see she was kind of on the outskirts a little bit. And there was just an opening prompt from myself: how could you make these pumpkins move? And I guess that was my way of kind of bringing her into what was going on, because I could see she was there, but you're not just fully immersed. But for all I know, she could have been really sat at the side studying and understanding it and making meaning of it. So I just give her an opening kind of phrase. What she did with that really was up to her. I didn't say she had to come and do something in a specific way. But gradually over time, she kind of edged her way in to pick up one of the very small pumpkins, as you can see, because it was in autumn at this time. And she started just dropping it off some blocks that had already been built there. They were already sat there. Again, just watching her, letting her do that. She is a quieter girl. And then she just announced it just dropped, it didn't work. So that was kind of my cue to go in and join her and unpick that and ask her a little bit more around that. And I think, again, earlier on, that boy was wanting that car just to drop. She clearly didn't see that that drop of that pumpkin was effective, yet it's interesting, isn't it, how they were both doing ramp play and one boy thought that was a fit way of doing that and this girl doesn't. And I think that goes back to that kind of debate and just different points of view almost. But anyway, she wasn't happy with that. So then I just went back in and with a very open-ended question, not telling her how to make things different, but just saying, oh, no, what could we do? Is there a different way to approach this? So then she starts to play around with different bits of material, pulling on different things and almost becoming part of the play in a bigger way. And then giving her time again, and then much later on, just asking her, what did you do differently? And I think by just something as simple as that, it gives you a degree of understanding, again, as to what it is that she's been unpicking. Yes, she's been quieter, but she's clearly been taking something on board and she's been going through that process of understanding what the others were doing and then trying to test that out herself a little bit. And then funnily enough, I know we haven't got that this kind of example in these slides today, but she went on and on testing this out several times across different days and weeks, to the point where she then actually became a real leader of ramp play within that particular space. And I think she kind of has obviously over time grew in confidence, flourished in her own beliefs, and she became the one where people would go to and say, what do you think about this? Can you tell me how you've worked that out? So she became a real leader of that kind of project at that point. And I think that for me was quite inspirational in the sense that this was the start of her very early stages of coming in and joining that bigger group, but clearly had been absorbing a lot from others before that. So again, I think it's been very, very sensitive to children, that you will not always have them giving you words and giving you vocabulary and being heavily involved in their actions, but it's respecting that they will come when they're ready and they will expose to you when they're ready, if you can do that in that sensitive way and pull them in very, very gently. Then there's another example, which again, personal favourite. I was very excited when all of this was going on, I'm not going to lie. It was near the end of the school year, so there'd been lots of exposure to lots of different terminology around ramps, which is all in your book. And I think if I could see anything, if you can take some time just to have a look at that and really read it yourself and unpick it yourself as a practitioner, you will learn. And I think that what I've realised is my maths kit, if you like, my maths bag is growing, but it's never full. There's always room for more. And I think, yes, we've had children since this project, where we looked at maths in particular for that year, come in and they've had different fascinations and wonders and interests that we've built upon. But ramp play is always something that's gone on in the background of everything else. It's always something that children do, no matter what cohort of children we have or how they present or how, whatever their backgrounds might be, they play with ramps in some way, shape or form throughout all of our provision. So it's something now that we can draw on. And would I have joined children in ramp play in the way that I do now back in 10 years ago? No, I wouldn't. I would have been that educator that would have thought, oh yes, they're building ramps, brilliant. I can see that they've really got a good structure there. It's balanced, it's it's stable. There's some things moving. I can hear some language about speed. And would I have left it at that? Yes, I would have. And I'll tell you that open and honestly. But would I now? No, but that's just because I've learned. And I think as children, we all learn things all of the time. And there's no, like, I'll hold my hands up and I'll say, like, I'm not ashamed to say that. But I definitely appreciate that we're all in a different place on different journeys. But I think, like I said earlier, amazing project. If you can get involved with it somehow, creep in, it's brilliant. Anyway, let's go back to this example. So this again was kind of the start of day one, and one example that the children had gone really from using kind of bigger 3D objects, if you like, to using very flat 2D things to try and build ramps with. And they were doing it on a table where they'd never used that surface before, on a light table, as you can see. So obviously they kept slipping and sliding. And I wasn't involved in this. This was self-initiated children's play where I knew it was happening, but again, I was just that observer. I was looking from afar thinking, what is going on there? But I'm quite excited, but I just need to let them have time to see what's what here. So again, I'm talking like much later, probably the next day or two. I then asked them, how can we make this a successful ramp? We know what ramps look like. We've talked about lots of different things connected to ramps. How can we make it successful? But again, what does success mean? So as I said that question, I then kind of straight away in my head thought, but what does success mean? Like, my success could be different to their success. So I thought, Catherine, again, back off, let them tell me what they're trying to achieve. Don't put those ideas onto them. But then, funnily enough, that girl came back with, it's successful if we can roll something down it like an orange. Because I thought, that's been her prior experience to ramps. They've all seen that ramps work when things roll, and that's how she sees a ramp to be. And then somebody else came in, I can do it, I'll slide it, but the shapes keep moving. And I think that was the tricky bit. They would get something to roll, but then the shapes would slip. So that kind of structure element really came into play, a big time on problem solving, but not just independent problem solving, which I think was the special part as well. It was very, very collaborative. There was lots of children now coming in, really trying to figure this out and unpick this a little bit more. And I'm talking a full, long weeks of period around this table, working this out with these children. But knowing that it was something that was very much at the front of their agenda, it wasn't something that I was putting on them. It was something that they wanted to unpick further. But I think from my point of view, it was really trying to give them the explicit language to support them in understanding why these things were happening, that cause and effect element. So talking to them there about there had been some prior work going on in a different space around gravity, and kind of children were dropping lots of different elements of weighted clay at the time, another project. So that girl then pulled on that, and there she's talking about, is that gravity? Is that like because it's being pulled down? But that came from some different work. So you see, children are multimodal. They will pull things together when it's right and when it makes meaning from them. And this was just a gorgeous episode where I could see so many things coming into play, and that collaboration and collective thinking was just, oh, it was just beautiful. Beautiful. Lovely moment. And then as an extension of that, because like I say, things don't just come to an end. We go back to things and we revisit and we revisit and we revisit and we rebuild when it's right. So this kind of was an example of where they'd found a structure. It doesn't show you clearly in the pictures, but they'd used some canvas boards. Some canvas boards had display on that you could see, but they just moved whatever they could that they thought was fit for purpose. So they used those canvas boards to kind of be that starting point to hold that 2D shape almost in position. You can see it wasn't particularly steep, but it allowed a dried fruit to move. Part of the process, which isn't in here as well, was that they were using lots of different objects to roll, and that obviously was then altering the ramp. It would flatten it, it would completely move it, shift it all together. They realised that they needed much lighter objects for this ramp to stay in position for something to roll as well. So they'd worked out that the dry fruit, which again was in a different space of nursery, and we all know that children are transporters. So here in our nursery, if they need to go and get something, they know where it is, they will go and get it, and they will bring it and use it into their play at that time. So these girls had brought this dry fruit through, and they were using that because it was obviously much lighter. And then to their absolute joy, it was working. It was success in their eyes. They had that ramp that was rolling something down. But again, it didn't happen over time. Lots and lots of exposure and play around that dried fruit going down, lots of different placement and arrangement of the shapes within the position and what order they were going in. And then at one point, again, lots of times I could hear that lots of conversation, and now they were starting to pull on that word, on those words of measurement. Really, they were talking about how far something had gone. And then one girl, we had, if you're like me, you'll have those free paper IKEA rulers dotted around any form of measurement. And one girl used that. And again, that was quite tricky to place it because it is paper. But she placed it on the table, and then she was talking about it's going to 2, it's going to 4. And then I thought, oh, hang on, they're starting to actually really measure here. And we're entering that kind of data analysis. And I know this makes Rachel really excited because it's that statistical maths is coming into play. But so again, I let them do that over lots of opportunities. And then I just said to them, is there a way that we could record this? Because I can hear lots and lots of conversations, but is there a way that we can remember what our measurements or your measurements have been when you've been doing these tests? So again, they knew the nursery well. So they'd gone and they'd brought back some blank canvases out of our studio provision, and they used a canvas. And you can see there in the corner of the screen that this is their interpretation of data. This is how they've captured their results. They decided how to capture it. Yes, I was alongside them and I was supporting them, don't get me wrong, but I didn't tell them to make their graph look like this. They owned this. This was up to them. So the middle column, as you can see, starts at 1 at the bottom and moves up. That's every turn that they had, but they knew that they both needed that first turn. They both needed that second turn. So outside of that column, you've got their own column. So you had a column that belonged to one girl and the other column belonged to the other girl. They would roll that down. They would both have that turn number 1, that turn number 2, and that is their recording of how far that piece of fruit has gone in that instance. And you can see the numbers perfectly formed, not necessarily. Are they clear enough that you can make out what they need to be? Yes, but ultimately, is it a recording? Have they embarked on their journey now of that statistical recording? Yes, they have. And does it give the information that we want it to give? Yes, it does. And was my point, like my job at that moment, to correct them on shape and orientation of numbers? No, it was to value what they were doing and that process they were going through and their thinking in that moment. And again, they were utterly immensely proud. That came back to be shared in our whole nursery community. But for me, it was just the fact that it was just something very new and different to everything else that we've done up to now at this point. but the fact that they had autonomy and that they knew that they could go and get things and bring them back to enhance their play and their ideas and to make deeper meaning of things was really like the wow factor for me. So I hope you're just as excited as I was about that process that those girls were going through.
I think I've put my hand up to say that Sophie can't get in first. But I mean, this is really phenomenal, isn't it? And I feel like I don't know how typical this is of like 3 and 4-year-olds really, but it seems like really kind of quite out there. But I think what Catherine said about the table is not how any of us would draw a table. We would put the names at the top. We would probably put the column for the roles as the first column, but it doesn't matter at all because it's got all the information in. And the fact that it almost is more exciting because it shows that they probably thought of this way of laying things out themselves, because if they'd seen a table somehow, they probably would have copied it a bit more faithfully, wouldn't they? So I find this just absolutely mind-blowing. But I think also, I mean, the way they're measuring is a very like standard way to measure of using a tape measure. Which is great. But there are loads of examples in the booklet, and I think even more that we could have used, of ways that the children find to measure, some of which don't involve numbers at all, and find to kind of have a data set of how far things have gone at the bottom of the ramp. And if children want to use a tape measure, then fantastic. But if they don't want to do that, if they've got another way to do it and they want to record the distances and make comments about how close together they are, or which things are going further, or whatever it is, then that's completely fine also. It's just really exciting. And I remember in this table I think there was a lot of comments about the numbers themselves. I think they say like, oh, they're all really big numbers. And I think they noticed that there's at least a couple of times where it goes 66 centimeters. And they noticed that. So they're kind of noticing, the sort of general tendency of the numbers to be in a certain area, and that there's some variation and things, making, even though I think, because they say 6 and I think Sophie wants to say this, but I'm saying anyway, they say 6 and 6 and 6 and 6 again. So I think they don't know that it's 66. They don't really have that idea of tens and units yet, do they? But they know that that's quite a big number. What was I saying? Oh yeah, sorry. They're still able to make observations about the numbers, which is really cool. Anyway, sorry, I'll put my hand down.
Yeah, that's exactly. I just was finding the ramp book, the page about this, and we've got quotes from the children. They say, look, 6 and 6, and then 6 and 6 again. That's 2 times the same. So they're interested that occasionally you get exactly the same result, but not always. Them are all big numbers, aren't they? So I think maybe they know that 2-digit numbers are big, though they don't quite know how they work. It travels a long way all the time. Now that's actually a general statistical conclusion, right? They travels a long way all the time, and they know that because they've written down all these numbers. So yeah, I'm not a statistician, and I'm still excited by what they're doing. Yeah.
Yeah. Do you want to seize back control, Catherine, or shall I move on?
We'll move on because I can see the time. Well, let's.
Oh yeah, okay, good point. Right, back to Sarah. Sarah's not had a say for ages.
Sorry, I've now got crying children in the background.
Oh no.
No. I'm in nursery. Okay, trying to bring it to a close. I hope you've all enjoyed kind of hearing the examples, and I think they are really small snippets of everything that's happened. So I think if you can get the booklet, there's lots more key vocabulary to look at and things. But I think again, looking at maybe your own practice and thinking, right, this is something we're wanting to look at. What can we do? We just thought this slide, might be kind of helpful. So you've got a few, resources there. Ultimately, it's about having those key materials open and available. Catherine's touched on it. Children need to be able to have access so that they can go back and find things and know that if I go there, I can get what I need. They want, that's really important to allow them to follow their own lines of inquiry without permission. They don't have to ask. So I think it's really thinking about how you display your resources for the children. Offering new resources at the right moment to solve a problem or help an exploration. Again, timing is crucial. So that last example, Catherine hadn't given them that tape measure weeks and weeks beforehand. It's about your observation. You're observing your children and knowing when it is right to add that next resource in or that canvas. If that had happened too soon, it wouldn't have, it wouldn't have meant anything for the children. And that's about that responsive teaching. So I think it's just really remembering that scaffolding the learning, without taking over, you know, without thinking I must do this, I've got to get the children to be doing that. It's when things happen organically and naturally, it has much more impact for the children. Set up a simple ramp to provoke curiosity. You might be sitting here thinking, actually, I don't really know if I've seen an awful lot of ramp play. And you might want to see what your children will do. So, you know, I think sometimes children just need that small provocation, almost that invitation to explore, to invite them in and to say, come and kind of have a look. And then think about those questions. What moves? How does it move? You know, how far? We've obviously touched on that. And like I said, there's a big section in the book around that. And then time, I don't think we could finish without, you know, going back to this. For us, this has been the most important factor. You know, giving children time to be curious, to experiment, to reflect, that can't be rushed. And I hope we've tried to kind of capture and show you today that if you don't rush children, and you go with them, what they are capable of is just huge. And I think it's down to adults to enable children to have that long, uninterrupted periods of play. That moves that mathematical thinking into real deep level learning. So yeah, time it is so important, and it's a free resource, so that's always useful.
Okay, I think this is my slide. Really just quickly summarizing what maths we think you can, the general areas of maths you can find in ramp play. When we were putting together the booklet, we found that we ended up with several little sort of chapters focused around different kinds of maths. And these are basically the little chapters. They're each, you know, four little A5 pages long. So we talked about angles. We talked about speed, we talked about length and distance, and we talked about these things because the children were talking about them. Measuring and recording data, we've just been talking about that. A bit more about shape. There's a little bit more about actual mathematical shapes like squares and hexagons and things like that towards the end. And lots about comparisons and fair tests and how to do experiments in a fair way. So if you have had any doubt that there is a lot of maths in ramp play, I think this list shows you that it's true. So yeah, please, I can see in the chat that people are wanting to get hold of the booklet, which is great because I think you should get something out of it.
So yeah, just some very, very final thoughts. So yeah, as Sarah said, if you might be sat here thinking, oh, I haven't been invited to the ramps party. There are no ramps in my nursery, but it'd be very surprised if there was nothing you could build a ramp with, because you just kind of need something flat and something to prop it up against. So, you know, maybe just start small and put a ramp somewhere and it's always pumpkins, but it won't be pumpkins at this time of year, will it? I don't know what the fruits of the spring are, but you know, just see what happens. I think we've hopefully we've said this lots, but I'll say it once more again, is just children seem to have no shortage of kind of maths questions and ideas. They seem to naturally be questioning things and drawing ideas together and looking for relationships and trying to predict things and comparing things and all that sort of thing. It's all very mathematical. And actually one thing we haven't said too much is if you're not, maybe one thing that's kind of scary about embarking on thinking about maths around something is that you might not know the answer, but that's fine because you can work it out together. If a child says, oh, will this heavy thing go down the ramp faster than this light thing, you might not know, but that's okay because you can build some ramps and test it. And there were some things not just in the ramps, not just when we were talking about ramps, but there were some times when the meetings, when, you know, we always have maybe 3 or 4 mathematicians in the meetings, and there were some times when we didn't know what would happen, and we had quite a lot of fun talking about, you know, what might be the important variables and what might happen, but we didn't know. But that's kind of it. That's, you know, that's okay. A lot of the fun of maths is not knowing, because then you can try and figure it out. I don't know if that's, yeah. Anyway, so yeah, so there's a QR code for the ramp play. I know that the link's been in the chat a few times, and I can see that Claire's been directing people to the piles of ramp booklets that are hidden around Birmingham. So that's fantastic. It's much nicer to have it in print if you can, I think. Yes, and it's full of, I mean, quite a lot of the examples we've talked about are in there, but also lots of other examples. And, you know, we talk about the maths, we talk about children's development. yes, hopefully it's useful. And it's free to download, you don't have to pay for it. And then more generally, so if you have clicked on the link, you'll see that it's part of the Young Minds Big Maths website, where we're kind of gradually writing kind of just hopefully quite short, I don't want to say articles really, but snippets maybe about maths in everyday things. So there are some ramps on there, but there's also leaves and flowers and clay and milk and children dropping things in puddles. So yes, if you have enjoyed this and want to think about maths in other parts of life, then that might be interesting. But yeah, thank you so much for having us. It's been really lovely to talk about ramps.